Hmm? Yeah. Yeah, it would be good if you could.
If that won't, if you really want to run them off of ours, I can download it all onto mine.
Maybe do that as a fallback while I.
We can use that as a fallback. Yeah. I'll go ahead and I'll make sure that they're all on here.
Yeah.
Yeah.
If that works, that's fine too.
Yeah,
I don't know if
that
you
would
need
work too. Yeah, well, I'll run it off of mine. Yeah.
Right.
And then you can.
All right, it's 10 o'clock and we have a pretty full agenda. There's some seats over here. It's sort of in the middle. If you want to fight your way in. There's even a seat in the very front row here, right in front of the access point. If you need connectivity, that would be a good one to have. I got reminded that the acoustics in here are pretty poor. They are especially poor if you're standing here as a speaker and you get floor questions because the speakers project this way. So we only get the echo up here. So if you're speaking there, please be slow and clear and clearer than I am. My name is Lars Ecker. This is Brian Trammell. We're the co-chairs of this BOF. We're going to quickly run through the agenda. This is the IETF. This is the Note Well. Things you say at the microphone or you send email about our contributions. You need to declare whether you or your employer hold IPR on the contributions you make. This should not be new to you. This is our agenda. We have an overview of Quic by Jana. Christian has an implementation. We have some talks about people that have experience with Quic in the wild. We have a little bit of a talk about the security plan for Quic. We have a plan for how we might structure the work, since this is a working group forming BOF. And then we have a lot of time for open mic. In order to have a lot of time for open mic, I would ask that we try and keep the questions during the presentations on clarification questions. And we will be pretty ruthless of making sure that it stays there. So we do want to have a long discussion, but we want to also run through the material first so that everybody's up to speed with Quic. Right. So the charter, and these are some key points of the current proposed charter text. The purpose of this BOF is to determine whether we want to define a new standards track IETF transfer protocol based on the existing deployment experience we have with the Quic code or proposal. There's 4 focus areas, right? The core transport work, and the wire format and basic mechanisms. Security, obviously very important, using TLS 1.3 to protect the Quic headers and payloads. The application semantic mappings, the initial focus being HTTP2, not surprising, and any extensions such as multipath for integration and load sharing. There's a note here on the bottom that I don't know if you can read. I'm going to read it to you. Consensus is required both for changes to the current protocol mechanisms and retention of current mechanisms, meaning that just because we have a pretty worked out input to this BOF doesn't mean that this is, sacrosanct and we won't be able to change it. There's no need to maintain wire compatibility with existing deployed code. So in other words, this is a regular IETF BOF where we have a very detailed solution proposal, but it's a proposal for how the solution could work. There's not an intent here to standardize what is currently coded. There's charter milestones. They are detailed. They're also, I would say, as usual, highly optimistic. We can discuss them later in more detail. ADs like to see that BOF proponents have thought about milestones. They have. We're going to ask a few questions at the end. At the moment, we think that we will ask these questions. This might change, but hopefully it won't, because we actually thought long and hard about these questions. The questions are, is the problem statement clear, well-scoped, solvable, and useful to solve? And a yes or no. Who is willing to review documents or comment to the list? Show of hands. I had a BOF in here earlier in the week, and the show of hand doesn't really work in this room because it's just so big. So if there's too many hands, we might ask you to, for example, send a quick email to the list instead and say, I'm willing to participate and in what role. But we'll do the show of hands first. Matt, question?
Matt Ford. I was just going to observe, sort of preempting the inevitable futzing around the questions when they come up. The first question is actually two separate questions. You might want to distinguish them. Like you could have a clear and well-scoped problem statement that's completely insoluble.
I can't believe we're at this point in the BOF yet.
So I said preempt.
Matt, counter question. Do you believe that a working group would be successful if any one of these conditions does not hold?
Slide 6, and we're already discussing. This is awesome. I'm glad everybody had coffee this morning. And the last question being, should the IETF form a working group with the charter discussed today? Right. This is the big one, obviously. And this is the last slide we have for the introduction. Any questions about anything we have planned for this morning? Otherwise, I would suggest we move ahead.
Yep. Now you can go ahead.
Yep.
There are plenty of seats up here for folks in the back. Up here in the third and the fourth and the fifth rows, you may not be able to see them from the back. All right. All right, I'm going to get started. My name is Jana Iyengar, and I'm going to kick this off with a brief overview of the Quic protocol. So Quic is basically, as it's being proposed here, a new internet transport. It's been an experiment that's been running for quite a while. As I go through these slides, you may recognize a lot of design elements that are shared, that you have seen before, that have shown up in previous transports, ideas that are already there in other transports, in TCP, in SCTP, and that's no accident. Quic has liberally adopted a lot of these protocols' strengths in building a new protocol that effectively builds on all of those strengths. Many of you may have seen us here before, may have seen this work show up here before. It's not the first time we're talking about Quic at the IETF. The first presentation was in November 2013. We were here last year doing a BOF. And we are here now doing the BOF. So let's get started. What is Quic? The Quic experiment so far, as we've done it, is basically to try and replace much of TCP and TLS, especially to make it work for HTTP, to reduce latency for HTTP, to make it so that we have low latency connection establishment, avoidance of head-of-line blocking, various other things of that sort. So the Quic experiment so far has, in the current instantiation, replaced a lot of TCP functionality. Quic crypto, which is a different crypto from TLS, replaced the TLS stack, and the HTTP2 stack, much of it was subsumed by Quic. Quic still offered the same semantics to an HTTP2 consumer. The proposal at the IETF, Quic crypto was done before TLS 1.3 even started. So now that we have TLS 1.3, which has zero round trip time and various other things that are very valuable and useful and were part of Quic crypto, TLS 1.3 has subsumed a lot of Quic crypto. So the IETF proposal will be to rip out Quic crypto and replace it with a standard TLS 1.3 handshake for Quic. So the Quic transport component is, so basically we are trying to componentize Quic here. The Quic transport will carry congestion control, loss recovery, multi-streaming, flow control, things of that sort. I'll talk about some of them soon. Use TLS 1.3 for the crypto handshake and have a mapping, initially at least, to HTTP 2 semantics. The goal is to have a standardized Quic that allows for the handshake protocol, the crypto protocol, to evolve. So for example, if we go to TLS 1.4, we ought to be able to plug that into Quic as well. And for other applications that are interested in using Quic later, to be able to use Quic as well. So the goal is to produce a componentized model, componentized transport that still remains secure in that the headers are protected and so on, but allows plugging in of other protocols.
1 second.
Yes.
If you have an empty seat next to you, would you raise your hand so that the people who are standing in the back can maybe find you? All right, you in the back, pick a hand and walk towards it. Continue.
Don't pick the same hand.
Go.
So Quic has a number of design aspirations, and these are the things that we've sort of developed it around so far. Deployability and evolvability are at the top of that list. It was really, really important for us to have a protocol that was not just deployable on the current internet as is, but that we could also evolve as we deployed the protocol. One of the strengths of Quic has been so far that along with the development process has been coupled with a deployment process that has allowed us to not only build and deploy, but to observe what happens to the deployment and to bring those lessons back into a subsequent version as we've deployed that as well. So evolvability allowed us to basically iterate on the protocol, and the deployability is an important thing again because we wanted reach. I'll talk a little bit more about a number of these things, a few of these things later. Low latency connection establishment was very important and remains important for Quic. Quic also has multi-streaming to avoid head-of-line blocking, and has per stream flow control to prevent one stream from taking over the entire connections receive buffer. Quic was also designed to have from the get-go better loss recovery and more flexible congestion control, so that we could play with congestion control at the same time have the best loss recovery mechanism that we can have based on everything that we've learned in TCP so far. Quic also runs on UDP, which meant that we had to have resilience to NAT rebindings, because NAT rebindings are a real problem when you hit UDP. And then we wanted multipath for resilience and for load sharing. It's something that we have again done in the MPTCP and SCTP communities, and those are those are protocols that have been designed with a lot of thought and consideration, and we have tried to pull in some of those things into Quic as well. So I'll go over some of these things. I'm not going to go over everything on the list, but just to give you a flavor for Quic. It's hard to go into the details of the protocol. In this forum, the protocol drafts should give you more detail if you want to look at those, but here we're just going to do an overview. So for deployability, we use UDP as a substrate. The goal there was to just have simple deployment through various middle boxes and to be able to get through most, if not all, middle boxes and NATs that are out there in the internet right now. And a really critical and important thing for us was to have a user space implementation so that we could have a rapid deployment and rapid updates sent to the client as well as at the server. Folks who have content servers can often change the server side rapidly, but the clients are not under the server's control. They're under operating system vendor control if you're trying to do the transport inside the OS. Having it in user space allowed us to have and ship updates rapidly to the client side as well. So having UDP as a substrate was really important for us, and so that's one of the key design features of Quic. Versioning allowed us to change the wire format on the protocol. As we learned new lessons, as we decided we wanted to try new things, versioning became an increasingly, versioning was a really, really useful way to make sure that the client and the server are speaking the same language. Again, one thing I do want to point out here is that these are all features of the Quic experiment as they are so far. As Lars pointed out in his early chair slides, going forward, if the working group is chartered, all of these things will be in the hands of the working group to decide what to do with. Importantly, Quic encrypts most of its headers and it fully authenticates all of its transport headers. What this means is that only the endpoints can modify any Quic transport header. Only the endpoints can see all information in the transport headers. Middle boxes may be able to see some bits of information in the transport headers. This was, again, a very important design decision which was made very deliberately to allow for evolvability of the protocol, to avoid network ossification of the protocol, to avoid a middle box that burns in some bits and therefore doesn't allow Quic to evolve and roll out new versions. Quic has multi-streaming. Any of you who are familiar with the CDB would know about what multi-streaming is, but for those of you who are not, multi-streaming is basically the ability to have different logical byte streams effectively inside of one aggregate connection. Multi-streaming allows you to have multiple objects in that the receiver will deliver data within each stream in order, but does not enforce ordering across streams, therefore avoids head-of-line blocking at the receiver when there are losses. Just like SCTP again, Quic has shared congestion control and loss recovery across the entire connection. And there are two levels of flow control in Quic. One is a connection level flow control that sort of tells the sender what the receiver on the receiving end of the connection as an aggregate, how much data it's willing to buffer before an application consumes it. And also indicates to the sender how much buffer the receiver is willing to allocate per stream before the application consumes it. This allows for a receiver to prevent one stream from taking over the entire receiver's flow window. On the congestion control and loss recovery bits, Quic has basically not borrowed, but totally built on decades of experience with TCP, congestion control, and loss recovery. It incorporates TCP best practices. The congestion controllers we have implemented right now are basically TCP-like. They are Neurino and Quic are the congestion controllers we use, and that's what's also going to be proposed in the working group as the congestion controller to use for Quic. Well, at least Neurino is probably the one that we intend to propose. For loss recovery, we've incorporated all TCP best practices again, although I will point out that while we implement FACT, TLB, FRTO, early retransmit, limited transmit, a whole slew of other things in loss recovery, Quic does not implement them according to the word of the RFC or draft, simply because the word of the RFC or draft map precisely to TCP. Quic's wire format is distinct and is different. It makes it harder to implement them directly, but it makes it a lot easier to actually implement the spirit of these mechanisms because the wire format makes it easier to implement loss recovery. And I'll talk about that briefly in the next slide. But yeah, so it implements the spirit of these mechanisms. Also, those of you who've been paying attention to loss recovery in TCP, for those of you who've been paying attention to rack, Quic also has, Quic actually has a part of rack automatically implemented because of the way that the wire format works, but it also has time-based loss detection that's the same as rack. And TCP is able to, Quic is able to do better loss recovery because it has richer signaling than TCP does. And by richer signaling, I'll give you two examples of richer signaling that Quic has over TCP. One is that retransmitted packets in Quic consume a new packet sequence number. This is distinct from both TCP and SCTP. This is an important difference when it comes to designing loss recovery and loss detection mechanisms, and actually simplifies things a great deal. It also allows us to use the same thing for crypto, but I won't talk about that here. The most important thing here in the loss recovery part, at least, of this is that it avoids completely the retransmission ambiguity problem, which allows us to do retransmissions repeatedly and avoid retransmission timeouts. We showed some data earlier that showed that Quic has reduced retransmission timeouts over TCP does, and this is one of the reasons why. This, by the way, is a part of RAC. Again, for those of you who are paying attention to RAC, this is a part of RAC that automatically comes with Quic, just because we don't have to do anything special for retransmissions, because they happen to consume a new sequence number, they just naturally get retransmitted like every other packet does. Yeah. There is also a more verbose acknowledgement scheme. The ACK itself is more verbose. It contains up to 256 ACK blocks as against TCP's 3. And while that's not as critical, well, I shouldn't say that. It actually is useful in a lot of cases. It does have explicit packet receive times, which means that if a receiver holds on to an ACK, such as in the case with delayed acknowledgements, waits for a while before sending back an acknowledgement, it encodes the amount of time that it waited on the packet before sending an ACK back, so that the sender has an accurate estimate of the round trip time, so that the sender avoids counting receiver side processing delay effectively into the round trip time. That's very useful when you try to reduce the number of ACKs that you're sending from the receiver, or if you're trying to delay ACKs, for whatever reason you might be delaying the ACKs. If you're trying to coalesce ACKs, for example, again, this is very, very useful because the signal is not lost. So that's what I call ACK decimation, is basically coalescing. ACK coalescence or ACK decimation becomes possible when you have this sort of signaling available in the ACKs. That's about it for the quick features. I'm just going to go over some other tools and implementations. The current implementations, the primary one that we've been working with is the Chromium implementation. It's available in the open source. It's available for everybody to see and use. It's an open source implementation. It's in the Chromium source code, and it's being used right now. Ian Sweat will later show you numbers on precisely how much traffic that goes to Chrome is basically Quic at this point. But yeah, and in this Chromium, there's also an open source implementation in Go, which you're welcome to go check out. This is being done by an independent developer, completely independent implementation from scratch. Christian Wiedema did an implementation as well, and yeah. Wireshark has a dissector for Quic. And Chrome itself has net internals, which are the client side. You can actually see full packet traces effectively, TCP dump style, with for Quic. And that's it for me. With that, I'll hand it off to Christian.
Right. While Christian's setting up, anybody have any clarifying questions? Be brief, but ask them. And there's also microphones at the far rows here, so you don't have to all go to the middle. There's still some empty seats up here, sort of in the middle on this side at least, and in the middle on that side. So if some people don't want to stand, you know, come up. You're not disturbing us.
And if you haven't seen a blue sheet yet, could you raise your hand? Okay. Could people make sure that blue sheets kind of make it over to, well, I guess they're going to the back of the room, but then over to this side of the room. Thank you.
All right. Do we have questions coming, or is it people that want chairs? It's people that want chairs, I think. Christian, go.
Good morning. I'm Christian Wiedema for Microsoft. And as Jana said, I started doing an implementation of Quic a couple of years ago with the goal of, does that clicker work? Yeah. So I started doing an implementation a couple of years ago because I wanted to really understand the protocol, and I also wanted to check that the documentation was sufficient to do an implementation.
Go closer to the mic, Christian, please.
I have to closer to the mic like that?
And raise it a bit, maybe. Yeah.
Okay. Thank you. So the reason for that, for me, it was really at that point a science project. It was not meant to ship any product or anything like that at the stage. And the general belief is that if you take a new protocol, actually doing an implementation is one of the best way to understand the protocol. So that was what I was doing. Generally, I did that also because intellectually, I like the general design. The idea that we have encrypted headers, that we have this very clean stack on top of UDP. It's something that's been around, I mean, for a long time. We have seen that based on the efforts on NAT traversal a long time ago, that we could do peer-to-peer UDP, but we could not do peer-to-peer TCP, or not so easily, and because of bilateral traversals. And so the thing there, the general design, the stuff that Jenna explained in the motivation, is something that I have a lot of interest in personally. So what I did is that at the time, the spec was what was published on the Chromium site. So I started from the spec, and my challenge was I wanted to do the implementation without looking at the Chromium code. So that I could not because that will be effectively cheating. I mean, you want to do that just from the text. And that generated initially quite a few discussions on the Quic forum, because I mean, you look at the spec and you say, what the heck is that? I mean, some of that was because my colleagues at Google wanted to have a very efficient protocol, so there's a fair amount of bit twiddling to get the header to be small enough. If you can't, the Quic header actually is smaller than the TCP header. UDP plus Quic doesn't have more header overhead than TCP. But that comes at a cost of a lot of bit twiddling that has to be specified in great details, and that has to be very well explained. And there are things like, who knows, who's here has seen how Quic encode the delta time between the time a packet has been received and the time the packet has been acknowledged. So, yeah, not very many. The reason for that feature is that it allows you to do precise time synchronization between the sender and the receiver, and to count exactly a precise view of the round-trip time. It's great. But in order to save the bits, whoever was doing that for Google decided to use basically a proprietary floating point format with exponents and mantissa and all that. I mean, that alone, that little piece of 16 bits, I mean, caused what, like 20 messages on the list until I understand what they were actually doing. That was fun. And there's a lot of that, but the good thing is that when you do that, you improve the specification overall. Then, of course, I work for Microsoft, so one of the reasons was for doing that is to evaluate if and when we should ship something like that in Windows. Jenna explained that it's in user space, so technically we do not have to ship that with the operating system. People could take an open source library somewhere, compile that with our application, and that's indeed what Chrome does. But if you do anything like that, you have an interesting problem of code update. Now, Chrome itself, the browser, has its own update mechanism. They get you a new version, etc. But imagine that we have 10,000 implementation linking with their own open source library, and we find a bug in the open source library. Well, what that means is that you have to rev 10,000 implementation. And in practice, that means that you will have a long tail of bugs that remain in the system and can be exploited. So that will be the main motivation for shipping a version of Quic with the operating system, so that we can actually update the DLL or something like that and have people, I mean, be up to date and be more secure.
You need to speed up a bit, Christian.
Okay, I'll speed up. I presented some of that a year ago. What has changed since? Well, things evolved for me in the right direction. The spec is getting simpler. I mean, the recent removal of the attempt at doing forward error correction inside Quic meant that I could remove maybe a quarter of the code in my prototype. That was a good thing. The other thing is that we have agreed on embedding TLS 1.3. That was one of my main piece of feedback a year ago, is that I didn't see for Microsoft that we would have two security stacks in parallel doing about the same thing, one for Quic and one for TLS. So having just one is great. Reduce the attack surface. And the fact that we have a proposed charter to actually have a standard, which is also something that we like. We don't want to ship protocols that are not actually well-defined, well-standardized. We have one question that we are asking constantly is whether Quic actually improves versus to TCP. If we can have a fully modern TCP with fast open, with good recovery, with TLS 1.3 that provides zero RTT, then we would have about the same performance as Quic. There's still some difference, but it will be about the same performance. Now, of course, there is still an argument for Quic, is that first, we could have that only on the systems that are fully updated. So for us, it would be Windows 10. And I understand that there are many applications that runs on ancient version of the system like Windows 7 that would not benefit from this kind of upgrades. And the other one is that you have dependencies on the install base of routers. So even if you have the latest version of TCP that does fast open, if the firewall in your home router blocks it, well, you won't use it. While it's running over UDP with encryption, provides you a path for fast innovation. So that's a good idea. And then there are features like forward error correction, partial delivery, that's head of queue blocking, that are really hard to do in TCP. They are not impossible, but they are really, really hard and are not natural. So it's easier if we believe that those innovation is important, it's easier to do that over UDP. So these are arguments for Quic, and we are following that and still interested. And yes, Lars, I know that I'm running out of time.
Be concise with your last slide.
Okay, so what are my next steps? I mean, what do we want to do? Well, I want to continue that work and now go to full interoperability test based on the IETF draft, not based on the common spec. I would insist in the working group on working on the extensibility feature. Jenna mentioned versioning, but versioning is not enough because versioning means that you have just one evolution path from version 1 to version 2 to version 3. And what we want to do is enable distributed innovation so that people, that Microsoft can try one feature, Google can try another independently. And that's a feature of the negotiation that we want to have. I want to work on Quic multipath with a special emphasis on privacy. I am really scared by the design of some multipath architecture that embeds some kind of a super cookie in the multipath header. So that's what I want to work on. And do performance tests to do that so that we get good benchmark and good documentation. But basically, that's why I want to see Quic in the IETF and I want to work on it. Thank you.
Thank you. While our next speaker from Akamai comes up, we can have some clarification.
I think it's a clarifying question. You said on your previous slide, features like FEC were an argument for Quic, but on the slide before that, you said that FEC had been removed from the spec?
Yes, the early specification of forward error correction has been removed from the Quic specification. It's not in the Quic draft anymore. And it gives a great simplification on the base protocol. However, in the charter, we have decided that we want to have a standard way to add forward error correction on Quic, independent of the way it was done initially in Quic 2 years ago.
So good morning, everyone. My name is Miroslav Ponek, and I work for Akamai Technologies. At Akamai, we make the internet fast, reliable, and secure. That's our elevator pitch.
Closer to the mic, please.
Okay, better now? So about a year ago, we decided that fast was not good enough. And that's why I'm here today. So I'm going to tell you about our journey of adding Quic protocol support to the Akamai's platform. And I will also briefly touch on some of the challenges we faced while doing this. And I will describe what the overall plan for Quic at Akamai we have. So what did we do exactly? So basically at Akamai, we have a lot of history of developing and deploying UDP-based protocols, and this has helped us tremendously with actually dealing with Quic. So we had a goal of keeping compatibility with the Chrome browser. And because of that, and because the documentation for the protocol is lagging behind of what's in the current latest Chromium code base, and because the protocol itself is evolving so rapidly, we actually decided to take the core Quic code from Chromium as the foundation of our implementation. Then we also took the Akamai congestion control algorithms that we've been using for TCP and for our proprietary UDP-based protocols, and we have ported them to the Quic framework. And we now have 7 different algorithms to choose from, utilizing latency, loss, and all sorts of content-specific information as the inputs. And this has clearly proven the point that Quic is a great experimental platform that can adopt pluggable congestion control algorithms. So it's not just about Neurino and Cubic, as Jana mentioned. So we also developed an SDK for applications on iOS and Android, such that they can, on the client side, enjoy the benefits of Quic. So we have deployed the server side, and we have an SDK for applications to be able to complete the loop and have end-to-end Quic. And finally, we deployed Quic to our server-side platform for HTTP delivery. But we are now at a very slow process. We have just started the process of enabling Quic for production traffic. So since we are at the beginning, I do not have any data to share yet, but I and will for Google's traffic. So some of the challenges that we have faced, I've already mentioned that the rapid evolution of Chromium code base for Quic has been pretty significant in our work on this. And the compatibility and version negotiation and all of the features that Christian mentioned should be handled by the proposed working group. Another big challenge that we faced, and this is actually preventing utilizing Quic for a lot of use cases, important use cases, is the lack of compliance with payment card industry standards. So we expect that TLS 1.3 adoption in Quic should help with this significantly. We also found that a lot of product features that we utilize are directly reliant on TCP as the transport. So not only you have to take the existing features, but also all new features have to be built for both TCP and Quic. So now you have the sort of duality. If you are developing applications, you are now doing this IPv4 and IPv6. Well, we actually see something similar with TCP and Quic. And as an example of such a feature, we have some security features that are, as an example, handling TCP connections and keeping them alive, doing some rate limiting and buffering, all in the kernel without any context switching. So this is not possible with a protocol like Quic, where everything is user space and fully encrypted. We also hit a lot of interesting challenges related to load balancing, and we would like to make changes to the protocol as part of the proposed working group to allow a load balancing within a certain infrastructure. So there were also some very positive things that we found that make the deployment of Quic easier. And that's the always available fallback to TCP. So if something goes wrong, UDP is blocked, or we just test some feature that didn't really work out, you can always rely on falling back to TCP. That's a very useful property. And second, Quic doesn't have to be deployed all at once. You can actually selectively turn it on for some fraction of the traffic by utilizing the alternate services header. That's very important operationally. So our overall plan is to participate in the proposed working group, and we will continue our work on performance optimizations. We were mostly focused on congestion control, forward error correction, and multipath. And we would like to move over from the current situation where we offer Quic as an option for some of our products into a mode where Quic would just be another default feature of all of our products. And we see great potential in deployments of Quic for many use cases. Thank you.
Thanks.
Any questions?
I actually have a quick clarification question on your last slide, slide 4. When you talked about the need to design for both Quic and TCP, this is because you are not using the HTTP binding that we're intending to specify. You're layering another application on top of Quic, and so you have to do that engineering, correct?
So the answer to that is that once you want to handle, I think it relates to the security, and that's where you want to be super efficient. Then you need to also go very deep, and sometimes you need to break some boundaries between layers, and you may need to sort of do things in a way that then prevents the easy layering that would probably have solved that.
Okay.
So it is about efficiency.
While Ian comes up, are there any other clarification questions? All right. Thanks for getting us back on time. I've seen this. I'm going to go get my blue sheets. Okay, cool.
All right, my name is Ian Sweat, and I'll be talking about deployment of Quic at Google. So we started our deployment in 2013. That was very early on when we got the first version of Chrome Canary to speak secure Quic, and we were very, very excited. And you know, it was like we'd actually made a protocol that worked. But basically, no one was using it except for us. In 2014, we started enabling it initially on Chrome for desktop in Chrome stable, so for normal users. At this point, it was still pretty small scale in terms of overall traffic. But you know, we really felt that it was to the point where it worked consistently. Users didn't, you know, experience any issues. Like, you know, it worked exactly as intended. And so this is the point we really started to gather performance metrics that, like, you know, we would use to inform future decisions. In 2015, we added Chrome on mobile, on Android, and Android search. So both of these applications are obviously, you know, very interested in improving latency, search in particular. And so those were kind of our first forays into Android. More recently, we're working actively on deploying YouTube with Quic. That's a big effort, and I'm heavily involved in that since I'm actually part of YouTube as well. And also Google Plus has started using Quic for all their requests. So here's some metrics on exactly how often we use Quic in Chrome to Google. So this is only Chrome to Google. But you can see we're basically hovering around the 85 to 88% range, depending on we're talking about bytes or requests. And so the vast majority of content is Quic. So what's the remaining portion? So PCI compliance accounts for a decent chunk of it. I'd say more than half of this are domains that have some amount of PCI compliance issue. So Miroslav alluded to that before, and that's exactly why we want TLS 1.3. Additionally, we actually have a holdback experiment, so you know, some of these people just aren't speaking Quic because they're not in the experiment. And as I mentioned before, it's enabled for quite a few Android apps as well. It's not just desktop Chrome, but we have the best metrics for desktop Chrome and the largest amount of usage volume. So what happens if UDP is blocked? Chrome just seamlessly falls back to TCP. The user never knows the difference. Same for path MTU. If the path doesn't support our default 1350 byte packet, the handshake will fail, the thing times out, and it looks exactly like UDP is blocked. And also clients can manually disable it, and admins can disable it, usual corporate stuff. So these are updated numbers of what I presented, I think, around a year ago at the BOF. And this is the question of, does it work? And the answer is yes, but 93% of people speak Quic for a given request, given that Quic is enabled. That's really quite good. So let's talk about the other 7%. only 0.3%, from what we can tell, are UDP rate limited, at least that we can visibly detect. 0.2% have UDP blocked by their AS. So that means that for the most part, on an AS level, almost no one's blocking UDP. It's being done usually at a finer grain level. And another 4.5% are blocked for a given user. So it could be a corporate firewall, it could just be a random router, who knows. But for whatever reason, that user just never seems to speak Quic. But the big thing to note is that UDP rate limiting has gone down by 2/3 since a year ago, at least according to all the metrics that we can gather. And that's really important because one of the challenges in deploying Quic is dealing with these edge cases where users have worse performance. And the vast majority of users have a better experience, but we don't want anyone to have a worse performance. So the more and more that the internet actually works well with Quic and UDP, and you don't have to do anything special and disable it for certain users, the easier it is for everyone to deploy. So we have a huge amount of measuring and monitoring. In some future presentation, hopefully I can go into that more, and I've gone to it some in the past, but we're very careful about monitoring error rates, connection close rates, application latency for different applications. I mean, we try to measure as much as possible, and that's really informed decisions like protocol evolution, congestion control changes, loss recovery changes, and it allowed us to catch a huge number of regressions where we add a new version and just completely screw something up, usually involving the handshake. So yay, TLS 1.3 again. And so in terms of performance, the performance numbers haven't really changed that much since around a year ago when I presented this slide. Some things have moved a bit, but for the most part, we're seeing about a 5% average improvement. Some sites are better, some are worse, and 30% fewer rebuffers for YouTube. And as I've mentioned in the past, zero RTT accounts for a big chunk of that latency improvement. It's worth noting it's not just zero RTT. Even a 1 RTT handshake is a substantial improvement over a standard TLS or TCP handshake. And the fact that 1 RTT is the worst case scenario is a really nice place to be. The improved loss recovery definitely results in fewer timeouts, which again really handles the YouTube case well because it's that long tail latency that drives rebuffers. And there are a variety of other benefits, some of which we're working on quantifying now, including head of line blocking. We've seen issues in TCP with RWIN, which of course you can't manipulate for Quic because, well, it doesn't really exist, but even if it did, you wouldn't be able to change it. Very efficient framing, and the fact that, as Christian mentioned earlier, the fact that we can deploy the same client everywhere in the world and have a relatively new implementation, and we don't have to deal with bizarre edge case bugs, really allows us to have consistent implementation in tight code. That's it.
Thank you. Question for Ian while Martin sets up. All right. We might end up being on time. It's hallelujah. Yeah.
You never say that when someone's getting up to the mic.
But that doesn't mean you get more time, by the way, just so you are aware of that.
So I was a little disappointed to hear that people talking about PCI compliance is the primary reason for doing TLS 1.3 after all the work that we've done to do all that analysis and all, basically discounting the work of all the people that are doing TLS 1.3 analysis and showing us that it's actually pretty good. So the background here is that Quic Crypto, the primary benefit that Quic Crypto provides is this zero RTT feature. I've got stars against these. It can actually take longer than this in bad cases. But the key point here is that round trips is the big win, and that's probably where the bulk of that 5% benefit that Ian was talking about comes from. TLS 1.3 was largely, was in part inspired by the design of Quic Crypto, and it has the same goals in mind. And as I said, there's several improvements over that. And I think that as people begin to use these protocols, they discover that there are a lot more use cases out there than just the ones that Quic Crypto was addressing. And so, though people complain about the baggage that TLS has, the number of features that it provides is also there. So, in thinking about this, we often think of protocols in the same sort of way. You stack one protocol on top of the other. And you have reads and writes and nothing else. You just put one on top. And this is actually a really important property that's allowed us to deploy HTTPS on the web. But it turns out it hurts. It really, really hurts. And it particularly hurts if you look at doing Quic this way. And I looked at doing Quic this way. You could do Quic this way, but there's a number of drawbacks with that. So first and kind of obvious one when I started looking into this is that the loss recovery in DTLS is primitive, yes, at best. And if you layer them in this way, there's this period when the DTLS handshake is doing its business where Quic wouldn't be able to see what's going on the network. It doesn't get all of the nice signals the network's providing. It doesn't learn about loss and can't use that to improve its response. That's not too good either. Oh, and yeah, the DTLS record format is a tad wasteful. People working on Quic often say that they're quite pleased at how easy it is to implement these things. We're going to try to fix this in TLS 1.3, but we have to run some experiments because unfortunately we have to deal with the internet the way we found it. And that's not always a pleasant thing. So this is actually the structure that we've proposed for this protocol. And it may be the case that this is the structure that we sort of use for new protocols that require these sorts of security services in the future. And you can see here that we actually have two interfaces from Quic into TLS. The first one is essentially the TLS handshake. And that is where Quic says to TLS, I need some packets to send so that I can set up. And TLS provides it with those packets and back and forth. The second one is once everything is happy and TLS has reported that it has moved into a state where keying material is available, Quic can ask TLS, please give me some keys that I can use to protect the packets that I'm sending. And then Quic is responsible for looking after those packets. Oh, I should point out here that the current Quic design reserves a stream for the purposes of doing TLS. And the plan here is to just put TLS on that stream. That's kind of important. So the benefits here is that Quic provides all of the ordering and reliability for TLS. We're actually using TLS, even though we're running over UDP. That means that Quic gets all the signals, it learns about packet loss, and TLS just provides it with the security services. Quic can use its own record protection format, which is optimized for use in Quic. Using the TLS record format would be unwise, given that we have packet loss, and TLS kind of assumes that there's none. Using the DTLS record format has some other disadvantages because we don't get things like the Quic connection identifiers and all those sorts of other indications that might happen in a clear. But ultimately, we're using all of the DTLS features for authentication and all those sorts of other things. And we're talking about doing things like using the DTLS cookie mechanism to deal with source address validation and things like that. There's a bunch of other things that are sort of baked into TLS that naturally lead to that working out rather well. And all of this is completely transparent to the clients. That the implementation of Quic simply uses the features that are available in DTLS and doesn't actually need to do very much to drive that. The draft goes into a bit more detail on that. Of course, with any project of this nature, there's a number of complications. generic exporters don't really work for zero RTT. We don't really have a good definition for that, and the security properties that are present during the phase where you're using zero RTT are not exactly the security properties that you might think you have, and so we might need something special for that. The version negotiation in Quic, which happens before we start talking at TLS, isn't integrity protected. So if we just put a little bit of extra into TLS, and we sort of provide a secondary layer of checking for that. And if there's any other things that we need to negotiate outside of the TLS envelope, that's the place where that's going to happen as well. The TLS handshake, flow controlling that is a little bit of a challenge, because you start the TLS handshake in a state where you don't have encryption, and you don't have any integrity protection on the flow control that might happen during that phase. When you enter the authenticated phase, it might be that there was someone, an attacker, tweaking the packets that you were using to inform yourself about the flow control windows and those sorts of things. And that might have effects that last beyond the point that you transition into an encrypted state. So conclusion here was, well, we'll just make the window big enough and not have to worry about it. And I think that's probably a reasonable thing to do. Probably the biggest problem that we've had is that the transition from encrypted to unencrypted to encrypted, and then between different keys, is actually kind of tricky. You can't retransmit a TLS handshake packet using new keys, because you're not sure that the other side actually the other side requires that packet in order to determine what the keys would be. And so that's probably the biggest thing that we have here. And there's also some synchronization problems when you get to key updates and things like that. This is the handshake. It is not particularly difficult. And you'll see here that we have a Quic packet that contains a TLS client hello. It's on stream 1. Let's send in the clear. If you have zero RTT, there's an extra packet or sequence of packets that might appear there that contain messages. Probably stream 3 in this case, because those are where you have put your requests. The server responds with a server hello and all the other TLS messages. Those might be encrypted if you're using zero RTT. If you're not using zero RTT, they'll be in the clear. And then the server provides responses to all those requests that you have. And you'll see here that we're talking very quickly. There's no mucking around in this thing. And this is the very simple case. There are a number of different ones that we could show otherwise. But then you get it finished, and then we're done. There's not a lot going on here that requires extra fancy work. It's just TLS with Quic. And that's odd, but I'm done. Let's leave that one up. Clarifying questions. Okay. I can see that everyone realizes that this is going to be a cakewalk, and we'll be all happy. Who's next?
Are the same restrictions on zero RTT in Quic as were discussed yesterday in TLS in terms of PSK only?
Yes. So this is absolutely the same design as TLS 1.3. Quic Crypto had a Diffie-Hellman-based zero RTT mode, and we've had a lot of discussion about that. And part of the reason why PSK is okay is because we made sure that Quic would be okay with that as well. TLS 1.3 was designed with Quic in mind as one of its goals. So yes.
Okay, thanks.
I thought you were going to ask about the replay properties of zero RTT. And
Oh, sorry. Oops,
that's another interesting discussion.
Allison Mankin.
Yes, thank you, Alison.
Colin Jennings, could you just clarify a little bit on what the extensibility model is here? Is like TLS one of the plugins that can be used, or the only one? And then I understood it right too, that the keying negotiation happens with TLS, but the actual encryption and integrity is completely outside of TLS, right, in a different design.
Yeah, so the way that I believe this is being approached right now is that this version of Quic will use TLS 1.3. It may be able to use TLS 1.4 transparently because the version negotiation in TLS is separate to the version negotiation in Quic. Won't be able. We could plug in TLS 1.2 in here, but that would be stupid because we're not going to get any of the advantages that the protocol.
Well, I guess I was asking whether you could plug in non-TLS protocols like previous other designs.
They would require all of the same properties that TLS provides, and I'm not aware of one that has all of that, but that may be possible.
Ted Hardy, just a reminder that that's ultimately a decision for a working group if it gets
Right.
formed, and that I would imagine that the discussion of that would exactly follow what Martin just said. We would want the same security guarantees because we would see the same threat model. So
Yeah.
I think that's kind of the key thing that the working group would have to consider.
Yeah, and Cullen also asked about the record protection. We plan to use record protection that's basically equivalent to that in TLS. Well, actually, probably more specifically DTLS, because that's a better fit for Quic. Which means that the analysis should be much easier. I won't say that it'll be the same, but it will be much easier for people analyzing it.
Janai, just to add to that, the current transport spec actually doesn't specify TLS 1.3 as the required crypto handshake protocol, but it requires, but it lays out a bunch of requirements of the crypto handshake. This is again obviously up to the working group what we do with this going forward, but it is separated from the Quic transport itself.
And I think the point of Martin's presentation is that we want to show that there's a good idea for how we would use TLS 1.3 in Quic, replacing the current Quic security mechanism, and therefore sort of compartmentalizing the standardization effort should it be chartered by reusing an IETF standard in this space and limiting the amount of work that we need to do in the IETF.
Yeah, so this is a document that's relatively small, and the hope would be that it would remain that way. The bulk of the work on the security protocols would want to happen elsewhere.
Just another thought that I think Ekar is pointing out that the transport draft at the moment already specifies TLS 1.3 may be the default crypto handshake, and if it doesn't, maybe that's a good idea for us to consider doing later.
So Colin's question about the packet processing, the subtlety with packet processing is as follows, that in TLS, the basic TLS assumption is that everything important is encrypted inside the packet. And in Quic, there's stuff you want outside, the stuff that you want integrity protected, but not confidential. And so, for instance, the sequence number, I believe, has to be public, so you can use that to key, to key the nonce for the packet decryption. And so, that leaves us with, so it certainly is possible to use the same packet format for TLS 1.3 and Quic, but the cost of that is putting a affordance in TLS for if you had some transport, which, so TLS is a transport agnostic, and so the cost of that is the affordance says, if you have a transport which has its own crap that it needs to protect, then here's how you feed that into TLS as the additional data that's integrity protected, not confidential. And so, I mean, as a practical matter, the crypto properties are essentially the same. It's just a matter of like thinking how you actually write that down in a standards fashion that sounds sensible. And I think, the TLS shares aren't here, but I'd be perfectly happy with writing that in TLS. I think people think that's better, or happy with copy pasting the TLS, the pieces of TLS into Quic that are relevant for that. They're basically identical cryptographically.
It's encouraging that we're starting the engineering already. However, I want to get us back on track for the BOF, right? Jana is next, and this might dovetail in this because his presentation is about how might the work items look like.
I forgot I had a presentation to do.
We haven't.
There's no coffee at the front here. Jana Iyengar again. So this is basically the proposal at the moment for the BOF includes, the charter includes several work items, and I'm just laying out here the current drafts that are being proposed as initial starting points for each of the work items in the charter. So the first one is the core Quic transport protocol, which covers things such as just the core protocol description, transport protocol description, specifically separating transport from the crypto handshake, this would just carry things such as the connection establishment, things such as multi-streaming, the stream and connection level flow control, connection errors, various other things of the transport sort. There are, and it'll also lay out what requirements it has of the crypto handshake protocol, as I was pointing out earlier at the mic. So again, mind you that this is still going to be defined as a secure transport, but it'll need to be combined with something else that provides the handshake and the key negotiation so that it can do the encryption. Quick loss recovery is basically the congestion control and loss recovery draft. This just covers standard congestion control mapping to Quic. By standard congestion control, I mean this is expected to, or at least the proposal initially will be to have Neurino described for Quic, and loss recovery, the standard loss recovery mechanisms that we know and love so well for DCP, but described for the Quic wire format. The Quic TLS mapping document is the one that Martin just talked about, which basically creates a mapping from TLS 1.3 to Quic, allowing an embedding of TLS 1.3 in Quic, as he just described in his talk. And finally, there's an HTTP 2 mapping that we didn't really go over here, but there are the beginnings of a draft there, which basically talks about how to map HTTP 2 semantics on top of Quic, because Quic subsumes some of the things that HTTP offers, such as streams. An HTTP consumer can simply, application can simply use Quic streams, but there has to be an explicit mapping between the two. HTTP 2 right now is described to run on top of TCP. So this will require an explicit mapping document as well. So those are the four initial documents that are being proposed to cover all the charter work items. A quick note on the scope and the area that this is being proposed in. At the moment, we are proposing all of this in the transport area because the goal is to produce a general purpose secure transport, which is why it is being proposed in TSV. However, well, there is a mapping of HTTP2 semantics, but that is really a useful driver to arbitrate when we have to make design decisions, when we have to figure out which design choice to take. And that's the one that we have the most experience with so far. The Google deployment at the moment and the Akamai deployment is all at the moment focused on HTTP as the consumer, as the application. The documents though are very intertwined and they will co-evolve as we move forward. So it makes sense to have them all in the same working group, even though, as you can see, there are a number of pieces here that will require application and security expertise. So HTTP2 and TLS expertise specifically. So despite that, this is largely transport work, or the core of it seems to be transport work, which is why it's been proposed in TSV. And that's it.
All right, thank you. That brings us to the clarification question, Paul, or?
Paul Hoffman, can you go back one slide, Jana? So it seems to me, and I only skimmed the documents, but I skimmed looking for, as you said, entanglements.
Can you come closer to the mic?
Yep. So I was looking for entanglements, and it seems like there's no way the first document, the main protocol document, can be finished until the second and third document are complete. To me, that says it should all be one document. There, from a procedural standpoint, we've seen in HTTP2 and in other working groups, they try to split it up by topic, and then it just sort of goes to hell. So I would propose that even though they are on different topics, they're just different parts of the same document. I didn't see anything in the HTTP2 mapping that was necessarily needed to be done before the protocol did, but I would propose to make it one document. I'm sorry? My clarification question really is there a reason to actually keep them split other than there is that it just seemed by topic?
But so a quick response would be sure. I mean, it was mostly about scoping the work items so that the loss recovery is very deep transport stuff. The Quic TLS is very much a document that talks about how to use TLS for the crypto handshake, which is required by Quic. And the separation is useful simply because tomorrow, if we have a TLS 1.4, it'll be good to be able to write only that piece separately and map it back into the Quic transport. Okay. Similarly for loss recovery, if you want to make changes to loss recovery, it'd be a good thing to not have to update the whole Quic core standard and just incrementally change the loss recovery or update that one particular module. That's really the difference. It's sort of like the difference between RFC 793 for TCP and 2581 for loss recovery.
Okay.
So it's nice to be able to update RFC for 2581 without having to touch 793, because God forbid anybody tries to touch 793,
I would
right?
like to table that discussion, because if a working group gets chartered, it can decide how to best organize the work. And this is, one proposal that looked good to the proponents, but as Paul said, right, it's up to whatever the group wants to do. Some groups like Network File System have tried to do monolithic documents, found it very hard, have split them down. Other groups go the other way. So we have running code for doing either one.
But I hear what John
if that's the hottest
says,
topic here for
right.
today.
I hear what John says is that the purpose is, though, so that there is the intention to have them be separable later in case they're replaceable. That was my question.
Okay. So question answered.
Do people want to ask more questions about Jana's presentation, or should we move to the open mic? Anybody on Jana's specific presentation? No, people are hovering around for open mic. So let's go to that. Did you have slides you wanted to show during?
I'm just going to put up the.
Yeah. So Brian's going to put up the framing slides.
Yeah,
and since I looked down, I don't know who was first because you all appeared in my field of view.
So for the Jabber folks, the network is pretty lousy in here. So there's like a multi-second lag. So remote participation is going to be inconvenient.
Okay.
Philhan Baker. I really like this for a couple of reasons. One of them, sitting in the TLS working group, I think it is clear that TLS has exceeded my mental capacity to be able to understand that protocol and all the details. And I think it has exceeded the capability of most people, possibly all people. So I think that starting again is a really good thing. The second point I'd make is I think that we should separate out the key agreement from the rest of the protocol. That must be a separate document. And the reason for that is that right now we have a whole bunch of security protocols, all of which have a key agreement, which could have been the same key agreement and are different protocols because they use different key agreements, but are using different ones. So, I mean, if you think about it, there's no reason why IPsec and TLS need to use a different key agreement. There's no reason why SSH and TLS should have diverged. We really need to get back to having one consistent key agreement, because if we're looking at security issues, we've got to have one place that we're looking at them. So otherwise, we're dividing up our effort.
This sounds to me like a comment that should be made elsewhere, frankly, because it's much broader than what we're trying to do for this effort, right?
Well, the question is this effort going to create yet another protocol that is doing things in a stovepipe way, or are we going to get to commonality and modularity at some point?
That's a better question.
Tom Herbert. So generally, I think this is going the right direction, but I think there's two things that are being oversold, not just here, but in other aspects. One is that UDP is the answer to run the internet. And two is the concept that we need to run everything in user space. So the user space issue actually is really a client-side issue. When you think about it, anyone who owns their own servers should be able to keep their servers updated. On the client, yes, we have a problem in that we know client OSs don't get updated frequently, so we need to run our own stuff there. So the reason this is important, though, is because when you move a protocol, a transport protocol into user space, you actually lose a whole bunch of information that you would normally have from the lower layers. So for instance, it's really difficult to get ICMP specific to your transport protocol in the user space. And I believe there's not enough interfaces for ECN and things like that. So potentially you lose some of the interactions with lower layers by moving to user space. So if I was designing this, I'd probably have the server side in the kernel, quick implementation and user space for the client. So similarly though, the concept of running everything over UDP, the way I look at it is one of the huge advantages of TCP is that we can run this both on the internet and in the data center. It's the same protocol. We've gotten a huge amount of leverage from that. It allows companies like mine to only support one stack instead of having two. So my suggestion there is, specific to Quic, is why not define this as a normal transport protocol. Give it an IP protocol number, and then make it kind of an option to run it over UDP when we're on the internet and we need UDP to get packets through the internet. So it turns out in the data center, UDP is actually a lot of overhead. So that model would actually make sense. So again, if I was running Quic in the data center, which if there's a lot of value in it being better in TCP, which sounds like it might be, I'd want to run that natively and not have the overheads of UDP. So I think Quic as a protocol number might make sense.
Okay, so if I can summarize your comment, is that so you're broadening the applicability of Quic to data center users and would like to see a different design that might make it more suitable there.
Right.
Okay. I'm actually wondering if we want to have because Brian and me are sitting here as chairs, not as BOF proponents or Quic proponents. So it might actually be useful to have the Quic proponents like Jana be up here so that you guys can directly answer these questions and not force me to make up stuff up here. Just saying.
But you were doing so well.
Yeah.
I was just going to stay.
I'm going to run out of fuel at some point, and then you wish you would have been there.
And Christian's gone disappearing. So I'll quickly answer. So you said that the idea of being in user space was being oversold. I really think that what you did there was articulated better. And I agree. We could have articulated it slightly better, saying that the client side was actually the big win for having it in user space. The server side, mostly I don't care, because anybody who owns a server farm can deploy things in the kernel as well as in user space. There may be advantages in certain deployments, but the big advantage of having it in user space is that we can ship it to clients who do not upgrade their OSs fast enough. And to the data center, I think what Lars says is precisely right. I think data centers right now do things that don't necessarily have IETF standards, and it's completely fine. And it may be useful to extend Quic to have a protocol number for data centers, but I don't think that that's going to fly for the IPv4 internet at the moment anyways.
So since Christian just came back, I'll invite him to come up and stand in the pink box with the other proponents. But I think that Christian actually made the same point that you made about user space in a slightly different way, that there are cases where you actually want this to be a service of the OS, sometimes in mobile, sometimes in desktop, so that you get the OS mechanisms for updating a common library. And I definitely think that's something the working group can discuss, but I don't think that we're trying to say here that the standardized version of Quic must never be in the kernel. That's definitely not the aim of the proponents in any case. We're trying to make sure that the deployability of it is not limited by the kernel deployment time that's common to the internet right now. So we're definitely.
I think that's fine. I would phrase it as Quic can run anywhere, and it should be the same thing with TCP. IETF protocols should not mandate where they run ever. They should be independent, and we shouldn't even call, like TCP is not a kernel protocol, and people call it that. It does not have to run in the kernel. There's never been a standard that says it does.
It's absolutely, the UDP encapsulation is what makes it possible to run it in user space, though not necessary at all.
Can I see a show of hands for people in the line who want to have the kernel versus user space debate? Again, okay, good, that makes me happy. Can I see another show of hands in the room of people who have not yet signed the blue sheets? Where are the blue sheets? Can we make sure that the blue sheets get to people who have not yet signed them? Thank you very much. Next topic, and we'll go with Dave's been in the back for a while, so.
Dave Crocker, I got up for something different. I want to register a request for the future, which is why I didn't raise my hand for the debate.
Can you go a bit closer to the mic?
I'm sorry. Oh, wow.
Yeah.
Okay. So I got up for something else. I will get to it. I wanted to at least register the user versus kernel. I always was taught and learned that being in user space is less efficient, that there's latencies that are involved. And so at some point, some discussion about the performance issues of being in user spaces versus kernel could be useful to document. That's all I wanted to say on that. The reason I got up was the focus on HTTP is understandable, justifiable, sufficient. To the extent there is any other thought or work that has been done on possibly some other popular protocol, a random thought might be SMTP, would be worth hearing about.
So one of the things that's been discussed both among the proponents and just came up again in Jabber was the possibility of using this with the DNS for the deprive-like use case, where you want a very quick deployment of something that can do a confidential request to a DNS server. So that's certainly one of the possibilities we'd like to discuss in the future.
To focus this on the charter text, I guess what we're hearing is that the charter might want to include something that the working group should think about applying Quic to other non-HTTP protocols, and might even try, or at some point it might have said something about that.
Yeah.
It did at one point.
Yeah,
okay.
and I think it's a good idea. In as much as you want a platform, you want to test a platform in several cases. And having something in the charter that says that we shall consider a second application, at least as a test case, is a good thing.
Okay, front mic again. Michael.
Michael Tuxen, referring to the kernel to user space debate. So what I'm missing, or what I think would be a good thing, is
Michael, can you come closer to the mic?
So referring to the kernel to userland debate, what I would like to see is some kind of discussion of the requirements of this protocol. So must it be supported in the kernel? Must it be supported in user space? Must you have encryption? Whatever. So not this particular thing, but before dealing with the protocol-specific realizations of these features, think about what requirements do we have. FAQ was in, FAQ was out at some point of time. So just have this at the beginning of the working group work, potentially with an outcome of a small document stating these are the requirements, and then doing the protocol work.
So Michael, sorry, this is Ted Hardy speaking. Michael, would the design aspirations that went up earlier be a good core kind of kernel of starting that?
Could you repeat that? It was hard to understand for me.
Oh, sorry. I said the design aspirations slide that Jana had up, would that be a reasonable kernel of producing that work for you?
Well, possibly a start, but I'm not tied to this point. Just a generic requirements thing that, you know, oh, we are heading for this. We want to have a better error recovery strategy with low latency, might, or whatever. So having these requirements to have a later on decision if we want to have this or that packet format, do we need this or that, or something like this.
Michael, are you arguing that requirements analysis and or document should be in scope for the charter?
Yep.
Okay.
Let's go to the back mic, Joe.
Joe Hildebrand. I wanted to second what Michael just said. Having a better sense of the requirements, I think, is probably a nice starting point. I do want to actually put on a Cisco hat for a moment. I don't normally do that at the IETF, but in this case, we're implementing along with Quic in our firewalls, sort of in doing similar stuff to what the load balancer people are doing on the other end of the conversation. And our goal there is to be able to advantage Quic versus generic UDP traffic so that we can treat it better than a normal sort of block all that we would apply to most UDP traffic. And we found a couple of things in that process of implementation that would be informative to a set of requirements, I think. one of the things we're hoping to do in the next week or so is to make that code available for people to be able to VPN into and be able to test their implementations through. We're hoping that that will allow folks to see what it would look like, and in particular to test things like resilience to version change and see how that would react. We're hoping that that will start a conversation around what the requirements for version change over time should be. What are the things that the path should ossify? Because in this case, the code we're talking about is the ossification function, and we're trying to ossify as little as possible to presume to allow for as much future work that hasn't been considered yet. I just mostly wanted to talk about that requirements question that Michael brought up and say, yes, I think that's a good idea. Any reactions?
So thank you. It's my first reaction. I really appreciate both your having code up for people to run tests against. That's always useful. And also that Cisco as a middle box vendor is interested in following the work early and not waiting for the final moment, because that's always a problem. And being in there early is really useful. If there are things in the descriptions as we go along that would be helpful for people who are doing these middle box analyses of what the implicit flows are in Quic, that can help make sure that the descriptions we write are useful for those implementers as well as the implementers of the end stations, that would be really useful, and we'd really welcome your feedback.
Thank you. And I did just want to say that there was a proposed change to the charter that's in a pull request that Brian had put in that had a couple of issues in it around manageability and these kinds of things. It's something that I think the working group, as it's being formed, should consider looking at that pull request and seeing if there are changes that should be made to that, or if it's an adequate starting point or whatever. I do just want to make sure that that the working group is able to think about these things adequately and knows that it's sort of on the hook at least somewhat to have those discussions about what should be exposed and what should be hidden.
Front mic, Mark.
Mark Nottingham. So one of your slides said that this is predominantly transport work. And I suppose objectively looking at that, it's true. You're coming up with effectively a new transport protocol. You're dealing with middle box vendors and probably a lot of privacy concerns. There's apparently an emerging talk about user space versus kernel space, which we can all look forward to. No? Okay. And by the way, you're doing a new version of HTTP. And it's not wire format compatible with HTTP 1 or 2, so it's a new version of HTTP. And I brought this up on the list. I remain concerned that it's easy for that to get drowned out by all the other fascinating discussions that are going to happen. It is not such a simple thing as, well, we just take the headers and plop them on a new transport. There are a lot of questions about extensibility that we are currently very actively still evolving HTTP 2. And I think they're very valid questions about, are we effectively forking it? How do we port those things over? Are we going to be duplicating a lot of effort? And I'm very concerned that although some members of the HTTP community are very engaged in this discussion, and that's fantastic, there are others who will not be. And I want to make sure they have a voice too. I'm not saying don't do it. I think this is great. By the way, I should have started, I think this is great. But I remain concerned about the relationship there, and that needs to be handled carefully. It doesn't mean we need to split off that draft, for example, but we need to talk about that more.
Yeah, thank you for that comment. I think this is, it's true not just for HTTP, but also for the TLS mapping. You're absolutely right that we need to have some serious engagement in the working group from HTTP folks. And we also need some serious engagement from folks who understand TLS deeply well, because this is not a simple layering of TLS, it's an embedding of TLS that's distinct from what's been done in the past. So the working group is kind of unique in that way, that it spans a few areas. And it's a new model for the IETF, and I hope that we can make it work.
So that actually brings up an interesting point, and I'd really encourage IETF leadership to think a little bit about this. In the W3C, this has happened a little bit. They have what they call super groups, where you glom a lot of work into one big group. And here we're talking about
transport, as well as you say TLS, as well as HTTP and potentially SMTP or DNS or whatever. And you suddenly have one group doing kind of everything. And that advantages certain kinds of participants who are highly active, and it disadvantages other people. Again, I'm not saying don't do it, but we should think about the implications of creating a group with this kind of scope.
Ted Hartigan. So I certainly agree with that, and I will note that the ISG has been thinking about this sort of thing for a while, and one of the options it has is assigning a group to a particular area, but having one or more of the area directors actually be from a different area. So it's also possible to have security advisors or application advisors, and I think encouraging the ISG to assign those for a group with this scope would be entirely reasonable.
And you can also help with splitting up how you do the work. With careful coordination, you can split off to separate lists or task forces or what have you.
We have an area director over there who gets an override, I think. Spencer.
Spencer Dawkins, Transport Area Director. I'm not here to override anything yet, but I do want to affirm what Mark was saying and point out that I'm pretty sure that we have a quorum of both the IAB and the ISG in this room right now, and so I am pretty sure that leadership at some level is hearing this concern and will be thinking about it.
Thank you.
Let's go to the back mic.
I just wanted to make a
second area director coming to the microphone.
Mia Kulevin, but I want just to add, it's not actually that unique. I mean, like we have other groups that are cross area, and we have assigned those additional technical reviewers. We can assign early chapters. We're very well aware of that. It's not a new problem. We're working on it.
Just one comment I wanted to make, and that's to a different question that Dave Crocker raised about having DNS, and it was brought up again. I think it's very useful to have an alternate application besides HTTP too, but the work group should also consider carefully adding many applications early, because it's important to actually get to the end of one thing. Sometimes that helps, but again, that's a question for later.
So during the time we've been waiting here, Mark so eloquently expressed most of the.
Hi, Richard.
Oh, Richard Barnes.
And stay this close to the mic.
Yes. Hello. Yeah. So Mark Nottingham hit most of the points I was interested in expressing here. So I'll just say +1 to a lot of what he said. I'm really concerned about. This is clearly a multidisciplinary effort that's going to need interactions with transport as well as applications and security, and it's a pretty even blend of those three things as far as I can tell. So yeah, I would encourage the ISG and IAB to get to do whatever procedural machinations to try and arrange for appropriate oversight from all of those groups, the ADs in those domains, and also to do whatever you can to get broad participation on all of those. Also, +1 on Phil Hallam-Baker's point about convergence here. I think it is really useful to have, as I think the word compliance appeared on a couple of slides here. There's already some drive toward sort of focusing on TLS as the common platform. So I think that, and sort of the common framework for doing security and focusing a lot of analysis on that and getting a really firm foundation. So I think getting established on that foundation is a really important aspect of this work.
And Jana Iyengar, just to respond to that, I think, yeah, I completely agree that the componentization and being able to do that with TS13 is critical. And I don't think it was anybody's intent to point out, as Martin was suggesting earlier, that PCI compliance is the main reason we are doing this in TLS13. TLS13 has received a lot of attention and will continue to receive attention, and that's very valuable. A general point, please come uncomfortably close to the mic.
Magnus.
Okay, Magnus Westler. I'm a bit. I find it interesting. I mean, you have experiment in a very client-server architecture. I think Quic is gonna quickly become something which is being used in many different use cases. What this doesn't seem to explore is actually how it's going to be able to work in more like peer-to-peer cases, etc., and fallback, etc. I mean, you end up with something probably for a peer-to-peer that you actually need a kind of ICE layer and especially multipath. So this is going to be snowballing into other challenges quickly.
Yeah, I must say that when I first saw Quic a couple of years ago, that was the first thing that came to mind. It says, hey, if we have an encrypted transport over UDP, there are clearly peer-to-peer applications to that. And that's clearly one of the use cases we should develop. But I mean, maybe not in the first round, maybe a parallel effort.
And I mean, my worry is about what assumption gets engineered into the base protocol.
So the one thing that I did point out on the slides, and I think we hope that the working group will continue to retain, is version negotiation and evolvability of the protocol. Part of the goal there is to allow for new requirements to show up later and to inform a later version of the protocol too. This is not to say that we shouldn't consider something like WebRTC or something peer-to-peer early on, but just to say that later is not too late.
Tedder, just to pick up on that, I think the evolvability point that was made earlier by Christian is that we actually probably want to think carefully about the extensibility model so that it's not necessarily going to be a version number that indicates whether something's taking a particular path of evolution or not. So I definitely think that that's in scope for any work in the IETF of this type, that we need to think about what the extensibility model and the evolvability model is, and peer-to-peer would definitely be in scope for one of the evolutions.
Let's go to the back mic.
Pat McManus. Oh, gotta swallow the microphone. Pat McManus, Mozilla. This is really uncomfortably close. Yeah, so the first thing I want to say is this is like really excellent work, and it passes a bar of running code at a BOF at a much higher level than is normally seen, but is the one we claim to aspire to. So thank you. That's really terrific. And I appreciate you guys bringing it, into this forum and the IPR issues that go with that and all of that. That's really terrific. And having passed those bars lets me say that we want to help and participate, at this point as well, which is great. And one of the ways we want to help and participate is diverse implementation. And it was great to hear this from Joe at Cisco as well. And I would encourage other folks to not just track the work on an intellectual level, but to produce, code and experiments and data of your own. I will reflect on the HTTP2 experience. This went as well in that effort as I've ever seen it go. We went to an early interim, and we realized we had a dozen somewhat interoperable implementations on the table, completely diverse, completely independent. And we learned a lot, of course, about our own code and what good or not good engineers we were, but we also learned about, the specs we were building. So I would encourage folks to make that go forward, and the yielding of change control into the IETF makes that double plus good. So that's exciting. I really do feel like I'm licking this microphone, so it is distracting me. Yeah. Oh, that didn't make it better. Okay, so on the topic of structuring of the work and cross-area work, I would point out this is not just 2 areas, but really fundamentally at least 3 areas, right, which add some complexity there. And we've talked about the challenges, which are super real, but I want to underscore the upsides there. We looked at Martin's proposal, or Martin's presentation earlier, and he talked about how essentially the strict layer led to this layering of, DTLS and UDP is one way you could do this, and how that led to the hiding of information and a bunch of inefficiencies. I think it's a pretty strong corollary to what happens when, apps does not talk to security, which was to not talk to transport. So I think this is actually a real opportunity for the quality of the work. So we got to figure out how to coordinate that, but I'm optimistic. Oh, right. And the last point. In terms of gathering data, I think one of the first items we ought to do is to figure out how to negotiate versions and experiments in a really strong way so that this can evolve and iterate very quickly.
So we have quite a few number of people in the queue, so people should maybe try and be brief and focus on your one burning point. And if we have time, you can come again and give us your second most burning point. Colin.
Hi, Colin Perkins. I'd like to focus on my one burning point that has 2 essential subpoints. Sorry. Firstly, there's been a lot of discussion about how to broaden this out from HTTP and talking about other application domains and so on. And I think that's very valuable. I think it's probably also important to go the other way, which is to think about if there are any application domains where this is not suitable or which you do not want to support, and to explicitly document those and rule them out of scope early, and to know what you are not supporting as well as what you are intending to support.
So Tetri, I think one of the things that would be obvious is any application which cannot use an encrypted transport, because this is fundamentally an encrypted transport, would probably be off the table, right? So please do not use this for TFTP. They have some other way of encrypting these days, but I think that perhaps the work that was suggested in the design aspirations document could then inform us in figuring out which protocols had substantially different design aspirations and therefore were off the table.
Yes, I mean,
yeah, multicast would be one more.
Yeah. Multicast
at the moment, at least.
Potentially things like very low latency interactive conferencing applications.
That's true, but I mean, in the interest of scoping the effort, it made a ton of sense that this working group does not consider multicast application, at least in the first places.
Yeah. I'm very much agreeing with you. Yeah, definitely multicast, I think, is out of scope. And I don't think that's a discussion to have here, but I think it's something to think about when you're, as the group is chartering, to understand what is in scope as well as what is out of scope. My second point was, I mean, this is taking a bunch of congestion control stuff from TCP. Sorry, this is taking a bunch of congestion control stuff from TCP. We've run into very widely deployed applications, such as a lot of the HTTP video streaming, that interact quite poorly with TCP congestion control. And I would encourage you to make sure that whatever evaluation you do of the congestion control for Quic explicitly includes those types of applications, as well as the much more traditional TCP applications.
Can you repeat that? What applications are you talking about?
MPEG-Dash and applications like that.
I see. So the applications that do congestion control over UDP in user space.
No, applications that use TCP in non-traditional ways. Chunked video, for example.
Sure. Absolutely, yes.
Right.
I mean, arguably, that's been actually part of our core evaluation as it is.
Lorenzo Coludi, I want to come back to the point raised by a previous question. I would observe that the reason, can you hear me?
Yeah.
Lorenzo Coludi? I would observe that the reason everybody is here, and this has got to be a huge amount of engineering cost, is because we can't change TCP anymore. And we stopped being able to change TCP about 10 years ago. Now, I would hope that as a community, we will learn that lesson and say that we need to make this protocol future-proof, and we need to make it completely camouflaged. Now, when somebody says, I want to accelerate Quic, to me that means two things. It means that any application that's in the future that can emulate Quic will be similarly accelerated, and that's awesome. And it's good because we built a new fast lane on the internet, right? That's great. And second, what it means is that we can never change Quic anymore because that middle box is going to stop working. Now, it is my hope that it is not too late to make the protocol robust against that sort of, let's say, interference. I hope that we won't have people in this working group saying, well, but you know, my middle box is going to work better and you need rough consensus, so I'm going to block your protocol until you give me what I want. I really don't hope we'll get to that.
Well, the one thing that all proponents of Quic agree is this business of encrypting the transport headers, precisely for the reason you mentioned.
Put the version number, don't put the version number in the clear. Like make everything encrypted.
Well,
if you can.
The other thing that we have seen in the negotiation part is that the version number is not necessarily the best way to do negotiation, because version number allows negotiation on a single axis. I mean, you go from the lower to the higher and things like that. Whilst what we want to do is negotiation of features pretty much in the same way that you can negotiate with TCP options. those features would be necessarily inside the crypto envelope.
Thank you.
So remember that there are two crypto envelopes here, right? There's encrypted in the sense of confidential to the path, and there's also integrity protected. And so one of the conversations that the working group needs to have is which pieces go in which part of that cryptographic envelope. And I think that it's definitely something where there's interest both from privacy advocates and others to make sure that as much as possible is confidential. And at this point, I will pimp my BOF tomorrow, which is a different BOF, which is looking at how we can look at the path layer much more generically. But I think the fact that we're proposing this particular transport in no way means we think the evolution of transport in the IETF should end. And this is a proposal, but we've already heard from others that there may be applications like multicast applications which will never be part of this effort, and we need to be robust against that as an organization.
So the queues are getting quite long. So I would encourage people to make their point quickly.
It's good to see that you guys are thinking about this. Just one point to make is that at the IETF, once the document is a working group document, a small group of people can hold you hostage forever. So think about that carefully.
Yeah, Matt, nice try with going to the front mic where there was nobody waiting. You're not up yet. Just keep on the back mic for a little while.
Okay, Göran Eriksson.
Yeah.
I like this work. And my burning point is the last bullet point on your slide here. You're touching on many important things here when it comes to transport protocol evolution. You have running code and you are discussing many things here. In the last bullet, you're mentioning two keywords for me, migration and multipath. Migration for me is mobility. Mobility can be anything from slow mobility, walking out the door, to really fast mobility, right? Now you add the multipath, which is not really a scenario we have explored a lot, especially not in the browser context. I'm afraid that multipath migration mobility will be lost, will not be in focus, and you'll focus on many other things in the discussion. And then we end up in doing a half-ass work, actually. So at least I would like to see as a deliverable requirements and use case discussion so we can scope that part of this work, if you include it in this space.
Jana Iyengar, so multipath right now is listed in the charter, and if what you're suggesting is that maybe that should be scoped more tightly around mobility and around load sharing. Sorry, that's certainly a reasonable suggestion, feedback for the charter.
Yeah, so one thing that we could think about is that, so similar how we are doing the congestion control based on what we know works for TCP, we could, for example, investigate whether we wanted to do that part based on what we know works from SCTP and multipath TCP, as a proposal.
Yeah, and just complementing that, as part of that one, I'd like to have clarified northbound API, right, to application protocols like WebRTC and HTTP as well.
APIs. Okay. Let's keep going on the back mic.
Ben Schwartz, Jigsaw. Of course, I'm very excited about this. I would, on the topic of evolvability, I would like to see a charter item that that empowers the working group to make protocol decisions to ensure that ossification that prevents certain kinds of evolvability is not possible. The example I have in my head personally is I'd like to ensure that we preserve evolvability to user space servers and peer-to-peer applications. And one thing that means is HINA reports. Right now, Quic operates almost exclusively on 443. And if that continues to be the case, we could ossify onto 443, which I think would be unfortunate.
Magnus?
Magnus Westland. So about the API, I think we actually need to do an API for functionalities in this protocol, because I think we need to understand how to use it. I mean, yes, it's a charter item to do an HTTP mapping, but what about the other usages? What things do you actually want to have, at least requirements for an API? So.
Okay, Matt, you waited long enough.
This might be a question for Ian, but I saw your presentation in ICCRG, and I think I asked a similar question there. So you've there's some deployment of this on Android. You presented some graphs which suggest that in the vast majority of cases, Quic just works, but does it just work on the vast majority of mobile cellular networks? And if we don't have that data, are there any operators in the room? I mean, I've seen at least one operator quite vocally and repeatedly saying that UDP is a swamp and they block it on their network. So it's just curious to me how that's going to evolve.
So yes, the answer is we do actually have a decent amount of data on mobile, even though it's not nearly as much as desktop. It's a huge amount by any other standard. I can certainly make sure that gets shared in a relatively timely manner, but I'll tell you that the percentage of people on mobile devices that can use Quic is, from all my experience, extraordinarily similar to on desktop. Yeah, so it's not that divergent. You do get less zero entities sometimes on mobile, but that's due to Android sort of specifics. Yeah.
As a general point, if there are operators who actually have concerns about these things, I think they should absolutely come up and engage.
Dan Drutza, one of the operators I represent. But the main reason I came here is related to what Ted mentioned about the plus, BOF tomorrow, and also the charter proposal that Brian has. I really support that addition to the charter, even though there's correlations with the plus. Since we don't have that work started, I think it will be good for this working group, if it gets formed, to have at least an objective for the manageability and troubleshooting aspects of the protocol. Because in the end, it's not just the endpoints that need to understand and optimize the resources. It's a little bit more complex than that. So at least we should acknowledge the fact that it's not just an A to B kind of a relationship, and the path somehow needs to be able to address the manageability aspects.
Do the chairs want to put up the pull request, just so that people who may not be as familiar with it
That would be.
can put it up, and we can go through the line, but have that going.
Thank you.
Right. So we had a discussion about this on the list, right? And at least my personal point on this was that I didn't know what it meant to have this text there. I know that there was an attempt to clarify what that would mean for the protocol in terms of talking about the ability to know when sessions started and stopped. And I think Christian replied to that email, and the takeaway was that most of it was already there. So yeah, so this particular sentence, I mean, it's Brian's pull request, so maybe to me this sounds incredibly broad, and I don't know what we would actually do with it.
So, and I should say what I said to Lars on the list is, yes, I see that it's broad. I need help making it narrower.
But one suggestion I think that came from Joe was that we rephrased that to say that the Quic protocol specification will describe the assumptions that it makes on the path behavior. Would that address your point? Who was at the microphone before? It was Dan, or?
Yeah, it was me. I think at least we should be able, with whatever wording we come up with, be able to describe some requirements. And that's probably why it's vague, because we don't have the requirements fleshed out.
Give me an example for a requirement. That was my reaction too.
Right. No, I can tell you, on the mobile networks, resource optimization right now, there are certain preconditions about how schedulers allocate resources at the channel level, and how things, it's very easy to say, yeah, I got this, this protocol works very well, and from server to client to server perspective, but we really need to take into account some of the.
So I think, sorry, Ted Hardy.
And I didn't want to duplicate the work that we're hoping to do in Plus. I just wanted to say.
We're definitely, we have a whole BOF tomorrow, come and talk about that. But I think that the kind of thing that Joe was bringing up earlier, and that is narrow in scope and easy for us to do, is to make sure that the wire format is differentiable to on-path devices so that they can tell the difference between this and attack traffic. Because that's really the core thing, right? Is there a way to identify that this is a quick protocol packet and not random garbage? So if I can offer a friendly amendment, obviously in the aspirations, deployability was a key element of this. This work will consider deployability and diagnosability of the wire format, both by end stations and path elements. Both by end stations and path elements. Oh, okay. So this work will consider deployability and diagnosability of the wire format, both by end stations and path elements. So the manageability of this is sort of not really the key element here, because different middle boxes will have different management roles, and that's not up to us to describe or discuss. But it is important that we be able to diagnose things that have gone wrong, that this was a quick flow that didn't get through, or that this has been identified by a path element as a quick flow, as opposed to, like, say, IPsec over UDP.
So I have concerns with putting the end system and the network in the same sentence, because you can already do this in the end system, and you have shown measurement that based on having that ability in the protocol. Giving the network that ability requires a completely different set of mechanisms. And specifically, you need to expose things to the network that otherwise you don't need to expose when you're doing it in band, because you are the endpoint.
I want to piggyback on that and just say one thing, Jana Iyengar, that I've tried to point this out on the list, on the thread, that this was around this text and around the network requirements draft, that the question of isolating or differentiating quick traffic is reasonable, except that whatever behavior we are talking about here ought to apply to pretty much any UDP-based protocol that we're talking about. It's not local to Quic. WebRTC uses UDP, SCDP, or DTLS over UDP, and I am a little bit concerned that talking about diagnosability or manageability or any of those things are first going to start with, here's what we need to identify and here's why, and the why is not agreed upon. I don't think that we have a list of middle box behaviors that are considered legitimate at this point. If you want to talk about what list of behaviors are legitimate, I welcome that. I don't think that the Quic working group would be the right place to do that. That's me as that's my personal opinion.
We have a quite long, just the people in line, is anybody on a different point than this particular one? Yeah. So maybe because we have the ability to consume the rest of the time on this, I want to maybe hear from the people who've waited for quite a while first, and if we have some remaining time, we can come back to this. So,
Lars?
Adam, you want to go?
Could I just jump in?
Yes.
Spencer Dawkins, Transport Area Director. I just wanted to point out for the group that I'm the sponsoring AD for both Quic and for Plus, and that I am aware that there's a seam there that we need to figure out. So if you're worried about that, please know that the area director is also thinking about it.
Adam.
Thanks. Adam Roach. So this is a comment for the IESG, who I believe is substantially in attendance here. There's been some discussion about the difficulties in managing a group that crosses so many areas, and I think that's actually a pretty tractable problem. We just need to talk through it. But I'm looking around this room. This is like a plenary, and I know at least 2 art groups moved out of the way of this. So when we talk about taking this group on, potentially as a working group, I think that needs to be coupled with a discussion of how we're going to handle scheduling in the future.
Yeah. I think we're going to have a quick day.
Just about.
Adam, do you really think that all of these people will show up to every working group meeting?
Actually, that would be a good thing to take a show of hands. It's like, we could turn this into a big, it's like who from art is likely to show up, who from sec is likely to show up, and figure out where the problems are going to lie. But I think that just the fact that it is so cross area is probably going to make it a problem.
So
for
I'll
some substantial-
trust the ADs to figure this out. That's why we pay them.
Colin. First of all, happy birthday, Adam. So Colin, Colin Jiggs, there's comment, two sort of extensibility points I'm really concerned about. One had to do with peer-to-peer. Obviously, over the long term, I'd very much like this to work in a peer-to-peer case, particularly for WebRTC and things like that. I can imagine voice going over it, other media. In fact, I know some vendors are already sending voice and media over it. So it's clearly something we want it to go to. I understand the desire to reduce the scope of the initial work to the minimum thing we can, but I think that we need to think about the peer-to-peer extensibility early. You can't just throw it in later. The way we threw it in later with WebRTC is we actually stole code points from TLS. We just stomped on top of them, and we were lucky enough that they weren't already used. But that was really not, being lucky is not a good plan. So I think that we should include that in the beginning. The other point I came up to make was around this firewall stuff. Okay, obviously there's a knee-jerk reaction of, we should encrypt everything and the firewall shouldn't be able to see anything. And I'm fine with that to some degree, but I want to maximize our odds of success of where this will work. And no, right now, so just listen to my argument here and have a very open mind about this for a second. Everybody that presented today said, we use the UDP and we fall back to encrypted transport over TCP when this doesn't work. Because the fact of the matter is, TCP actually works much broader than this does right now. And what I want to do is get it so this works as well as an encrypted transport over TCP. And the thing the firewall people want to know that a sequence of packets is grouped together in the same stream, or logical flow in the TCP sense, and that something on the inside actually sent an acknowledgement packet that it wanted to receive those, okay? If we had those properties, we'd have, I believe, a very strong argument to have the same success rate over UDP that we currently have over TCP, of a fully encrypted transport over TCP.
Great. And Chris, send an email that the protocol has that property.
Jana Iyengar, can we go to the slide from Ian's slide deck that shows Quic works?
Yes.
That's fine. But you're absolutely right. It would be wonderful to have universal UDP reachability. Not as a proponent, just my personal opinion, I'm not holding my breath for that. I don't know when that's going to happen, if it does happen. However, what I do know is that Quic has managed to reach 93 to 94% of users between Google and Chrome. That's a fairly substantial user population. Yes, there's a sliver there that we haven't reached. I would consider that if we are going to talk about that sliver, let's be clear that that's the sliver we are talking about.
I don't believe those numbers to start with, okay? They don't match my data. But second of all, if you have an application that doesn't work for 5% of people, that's a problem.
I have not seen your data first, Colin. I would love to see them here.
Just as another data point, multipath TCP doesn't work for 5%, and we don't have a problem with that in the IETF.
So what I'm saying is, how can we maximize the number of places this works, right? And we agree that falling back to TCP does increase the number at some level. And it doesn't matter what's 5%, 2%, 10%. Okay?
It does matter.
Really?
It does matter. TCP fast open doesn't work in a number of cases. Multipath TCP does not work in a number of cases. UDP will not get through even if you put in these things in your firewalls, because there are plenty of firewalls that are not being built by Cisco. So I'm not sure what percentage we are reaching for at that point.
May I make a suggestion that we now have at least 3 presentations for the next session of the recently chartered Measurement and Analysis for Protocols Research Group in Seoul?
So, Ted Hardy, who won't get nearly as much clapping as already said. I just wanted to say that I think that deployability was a kind of a key element of the work that went into the Quic experiment, and it's definitely a key design goal for the ongoing work we hope to have in the IETF. And I think the point you're making is that there may be cases where this is not deployable, and if there are protocol changes that would make it more deployable, then the working group should consider them. And I think that's pretty uncontroversial.
Okay, no, I think it's a more specific point on that, which is, should firewalls be able to identify this as these packets to be in one flow or not? I think that that's an issue that, you know, there's obviously strong opinions about. I think we should resolve it before charter. It's a pretty clear thing. I don't. Right.
So I'll point out, we're going to take a hum in 10 minutes wherever we are on this conversation. I think we can open a 30-second response to that, but we're ticking down on time, and I'd like to get to the point where we've aired all of the things. Are there any people in the back line who are going to say something that is completely new? We will judge how completely new it is, but yeah, okay. Let's do 30 seconds on each of those, and then we'll come back to this.
Okay, my name is Walter Kluten, Soft at Home.
Come closer to the mic. It's unpleasant, but you gotta come closer to the mic.
My name is Walter Kluten, Soft at Home. Congestion control, please talk to the L4S people, please talk to the multipath people. There's a multipath TCP end-to-end as you understand it, but I'm actually pushing a draft this afternoon on how operators are going to standardize how they intercept TCP traffic from hosts on the LAN. Put those over, aggregate over multiple.
Sorry, we really don't have time for ads. We are really short on time. And
next from the back line, please. Send it to the list if it's of general interest.
Kevin Smith, Vodafone. So just a couple of points. We've had Quic running in 30 plus countries for some time now, well over a year. It's working fine. Secondly, we'd say that actually as conditions degrade on a radio network, 3G, congested cell, etc., Quic pulls ahead of TCP. It performs significant performance improvements, so that's really important. But finally, I'd like to support Joe and Dan's draft on the network requirements for Quic, because certainly as Quic usage grows, we'd like to see that resilience.
Philhan Baker Komodo. I'd just like to suggest maybe you want to consider more than one group, in that people brought up the plenary aspect here. Maybe there are parts of the security that can be pulled out from the transport stuff, because I don't really care about where bits go or whatever. I just care about the keying. So maybe there'd be a way of getting the group, make it more manageable, because maybe not everybody is interested in every part of the spec.
Point taken. Let's go back to Lorenzo.
Lorenzo Caviti. So I'd like to point out that if a firewall in the middle requires a sequence of packets bidirectionally, you just killed RTT, zero RTT mobility. You killed it. Right now, you can take a quick packet and the state is at both ends. You change your IP address, you change your ASN, you resume that connection, bam, it works. You put that firewall in the middle, it's gone. You killed it. And so that's what I mean by evolving the protocol and ossification. We cannot afford to throw that away. Don't you want seamless mobility like that on your mobile devices? Is it really worth it to put some firewall in there that will preclude our ability to do this in the future? I mean, I would like that sentence struck. Sorry?
Yeah, none of us are proposing that, so you're putting.
What I said is, if you require a sequence of packets, like he said, that's what he said. He said a sequence of packets.
So guys,
sorry.
Let me suggest that.
Hang on.
That's it. Sorry. Yeah, sorry. If you require a sequence of packets, you kill zero RTT mobility. I personally would like to see that sentence struck, because the numbers here, unless they're contested by a reliable source, prove that deployability has been mostly achieved. Second point, I invoke Amdahl's law. If we increase deployability by 10%, we get 0.9%. Okay, we have to weigh that against the benefits of being able to evolve this. Okay.
So just to make it clear, so this is a proposed addition to the charter. It's not actually part of the charter that was circulated on the list. This was the, I think, last remaining discussion point that was open.
Yeah, I voted against it.
Since we're ticking down on time, right? I'm gonna propose. So this seems to be the only controversial topic that we've hit through the entire session, which is nice. I want to train the queue and give people a chance to have another word, but then I also want to get us to the hums. So,
Joe Hildebrand, I'll go quickly.
I think that there's an interesting conversation to be had here about what we're optimizing for on particular things. I think as we start to talk about multipath in particular, there are certain design approaches that might be able to hit both the desire to do quick restarts on other links, as well as be able to give firewalls what they need in order to do some authorization stuff. And I think that's a lovely conversation for the working group to have. And I don't want to preclude that. I don't want to presume that we know the answer, whether it's possible or not at this point until we do start doing engineering work. Whether that needs to happen here or in a potential TAPS working group, I think is very similar to the question of whether work happens here for the HTTP binding or not. And so there's some edge work there that the ADs will have to help us through. And I don't think we necessarily need to decide today, certainly not before a plus BOF, where that work would necessarily happen. I think it's enough to sort of have the general idea that we're going to work together, and we'll figure out where the right place to get that done, whether there's requirements here and work there or vice versa. I think we can all agree that the ADs can help us along find that path.
Thanks. Thanks for being quick. No, I'm not kidding.
Lee Howard. On basic principles, I sometimes feel like people think that network operators are the enemy. We would like to collaborate and work together. There's certain information we need to be able to see, and there's certain information we don't need to see, and we certainly don't want to see the private stuff. Enterprise operators are even less represented than than ISPs, mobile operators here. And they have different requirements that I'm not sure most people understand. The ability to actual troubleshoot, to see what's going on a network they own, where they own the literal data, is important to them. Back to firewall requirements. For usability use case, a diagnostics use case, being able to use Wireshark to see to troubleshoot a load balancer. That's my load balancer, my web server. I got to know what's going on. Which is to say, I want to keep that sentence in there, and we'll come up with specific language for how we address those things. I'm not actually proposing what bits need to go in and outside the encryption.
Janai, just very quickly to respond to that, I was distinguishing separate data encryption from transport header encryption because that's critical. This is not different from HTTPS in that regard, but in terms of just the transport bits themselves, as I was pointing out, I don't think that the network operators are the enemy. They are required, necessary, and they do important work. However, some of these things that you're talking about are coming out of individual people, and they have not yet shown up in a forum where we've agreed that these are the bits that we need to work around. We've not done that anywhere.
So I'm committing to help work on language and to solicit input from those people.
So Ted Hardy, speaking as plus BOF proponent, I think this is a general problem, right? It's not specific to Quic, and I think that plus BOF tomorrow is talking about one approach to it. If you are concerned about this issue and the general issue, please come to that, but please also understand that that work will take time to come to fruition if it's accepted, and that in the meantime, what we're talking about here is really that, can you use Wireshark? Yes, obviously there's a Wireshark plugin for it now. If you're on path, what do you need to understand about the packet as it's currently being deployed that helps you understand what the flow is? And I think us describing it in a way that's useful to middle box folks is not the same as making their requirements key to the protocol development. And what I've heard Joe just say and nod several times on is that what he's looking for is ways of describing this that are useful for people who do implementations along the path. And I think that that's really where we are at this point, and we can move the bigger discussion into plus tomorrow.
Mark Nottingham. So just a quick observation. Listening to this discussion, it occurs to me that there's a potentially very large difference between engineering a protocol that is intended to be used for any new application and run on its own, and engineering a protocol that has a fallback to TCP. And HTTP, you've got an obvious fallback. It's existing protocol. And so if a firewall or anybody else wants to make an engineering decision, say, I'm going to trade off the potential benefit of using Quic, that's okay. My users will transparently fall back. And it'd be interesting maybe to think about what's intended here, because that might have a drastic impact on the conversations in the working group.
and it might make things simpler. Do you have any comments about what your intent was?
Ted again. So I think it is interesting that many of the protocols that people have proposed as use cases have a fallback. So if you were doing DNS in a deprive-like way here, you do have a fallback to either DNS over UDP or TCP. If you were interested in something like this for WebRTC-like mechanisms, you do have a fallback to the current stack, which is SCTP over DTLS over UDP. So that it may be that we're currently thinking of things that are applications that would have a fallback. The critical next step is there an application that runs over Quic which does not currently have a fallback? And honestly, nobody has come to me with a use case of that yet. Doesn't mean it won't happen.
Jana Iyengar, I think that's actually a very good point you raised, Mark. And I think I'm wondering if that actually could become one of the requirements, saying that if you as an application do not have a fallback and require UDP to work, it may not. So HTTP2 is right now on the charter to be the one primary application. And one of the reasons, again, for driving into the HTTP2 was because we had a fallback to TCP, and that's how we've deployed it. That's the running code, and that's the deployment experience that we currently have. Everything else is wishing and not knowing exactly what's going to happen. And I find it hard to sort of figure out exactly what we're going to do in those situations because we have no experience with that. On the one case that we do have experience, we know that there is a fallback required. It's hard to say what we would do without a fallback.
If it were me, I'd want that in the charter.
Do you want us to sit down now that you're asking consensus questions, or do you want them to consent to us as well? I have a hint of which I'd prefer.
But Adam, do you have something really quick?
Just real quick to add to that. I mean, it's existing protocols are existing, right? So it's kind of of course they're going to have a fallback. We're not going to define a protocol without a transport underneath it somehow. Now, if we were, for example, to define WebRTC after Quic had been specified, it would have been the obvious thing for data channels. And having to specify two different things to go under that because this one works 90% of the time would be a royal pain, right? So I think it's a valid point. It's just we can't think of these things because we can't see what might happen in the future.
Jana Iyengar, to respond to that again, it's very hard to predict what's going to happen to that 10%, no matter what we do here at the IETF. I do not know how we can ever talk about how to reach those 10% without actually finishing reaching them.
Okay. It seemed to get lost in the conversation that, you know, obviously things that are defined are going to have a fallback. It's tautological.
So
that's a fair point.
This was an interesting session. I'd struggle to summarize it, so I won't. But so we have a concrete proposal for if you want to sit down, sit down. Thanks for standing in the pink box for so long. So we have a charter that was posted on the mailing list. And I think I want to use that as the basis for the hum. It's also clear that that charter has at least one outstanding change request that needs more discussion. But I actually agree with Joe that this is something that the working group, if it decides to get chartered today, could discuss, right? So I actually want to propose that we don't try to edit any charter text now. We're going to use the charter that was posted on the mailing list, and we're going to hum on that. And I think you're bringing it up here, not that people can read it. And it's much easier to recharter a working group than to charter a working group. So if the discussion that we're going to maybe have inside a working group leads us to some clarity around the issue, what we need to do to make Quic better for operators, I think anybody involved would be, happy to recharter a work item to make that part of the work.
I have a clarifying question. This is Joe Hildebrand. This is for the ADs and Spencer in particular. Do you agree that the charter as currently constituted allows for this conversation, or would you be open if somebody was to charter, if somebody was to say, that's out of scope, we're not going to talk about that using this charter, would you be supportive of that argument?
So two things. I'm sponsoring AD for Plus also. So we have a certain number of these conversations that we need to talk about whether they are Quic specific or whether they apply to anybody who's dorky with it, something, a new UDP-based transport. Okay, so I'd like to defer part of my answer to tomorrow about this time. Feel free to answer the question again, but also recognizing, you know, we're talking about sending out, you know, whether this is a charter to send out for comments for do an IETF last call on. So if we can, you know, we can have those conversations, we can have that part of the conversation with it then as well. You know, we get comments on charters that we
I
send
didn't
out.
hear you say that what Lars said is.
I'm not disagreeing.
All right, you're not disagreeing with Lars. So you're agreeing with him.
Spencer,
Sure.
May I try to clarify what I think I heard you say back to you in a way that I would understand it better?
Sure.
We're going to hum on a charter now.
Yeah.
Between the time that that charter is hummed on and the time that it is the actual charter text that the working group works to, there is a process that it must go through.
Right.
And changes to address this may happen during that process.
So that is an open process.
Right.
Ted Hardy, a friendly amendment. I believe what I heard Joe asking was actually a slightly different question. And the question Joe
falls apart at the end.
Joe is asking is whether the conversation about deployability, manageability, diagnosability is permitted under this charter. My personal answer to that is it is, but he's asking Spencer, not me.
So my personal answer is yes, it is, because it doesn't specifically provide exclude it, right?
Thank you.
So
Well, the ADs could change tomorrow.
Okay. Okay.
So I note that we're about 9 minutes away from the end of the session. And if we had hums for the ADs to think about after the end of the session, that would be awesome.
Yeah, that's what.
Yes. Okay. So we're going to do that right now. Jonna, would you like to hum really loudly into the microphone?
It depends on the question.
Is the problems okay? So we're actually gonna go into these. Yeah. Okay. You can see them better. Well, the microphone. So Lars will ask.
Great. Because I never mess these up. So we showed you these before. We're gonna ask these as written, except the last one. Specifically, I'm gonna ask you to hum on the working group with the charter as posted on the mailing list, and not discuss today because we didn't wordsmith it, and it was not clear what that would mean. And then I want to give the ADs a clear signal on something concrete, and that the last concrete instantiation of the charter we have is the one posted to the mailing list. So based on what you've seen in terms of the presentation and the discussion today, do you think that the problem that this working group is intending to solve is clear, well-scoped, solvable, and useful to solve? Hum if you think that is the case. Hum if you believe this is not the case. That was very clear. I didn't hear anybody hum no, and I heard a lot of people hum yes. And one person, was there a nose in the back that I didn't hear? Okay, the acoustics are really poor, so thanks for bringing that up, right? So rough consensus clearly established. Okay. Second question. Who's willing to review documents or send comments on them to the list? Show of hands. I would say at least 50 people. I would eyeball at 50. Do panorama. Who would be willing to edit documents? That is also a sufficiently large number. That is at least 10 people, probably like a dozen, I would say.
I'm saying a dozen. Keep them up.
All right. While you have the hands up, you can hum. So I'm going to keep asking the questions so we can get to lunch first, because otherwise, I don't think we're going to eat. last question with the edit, right? So should the IETF form a working group with a charter as posted to the mailing list? Please hum if you agree. Please hum if you disagree. I hear some. But it was very clear for, and there was, I think, finger pointing in the back means there was probably noises in the back too. But I would still declare very clear consensus for this. Is there anything the ADs want to hum on in addition to what we just hummed on, or why are you both standing at the microphone? Anything else you want from the room that would help you make a decision?
Lars, Dan York over here, just to also record in the record, there were a number of hums, all yes, in the Jabber chat room. So just to record that as well.
Great.
So Spencer Dawkins, Transport Area Director. I think I'm good with where we are at this point, and I do want to encourage people to watch for the discussion of the the call for input on the proposed charter as that moves through the process.
Okay. Thank you all. This was I think it was a record number of attendees. So this is
And if you have not signed the blue sheets, please come up and do so that we can make the run to record number of attendees. We are currently at 254 plus 306. We're well over 360. We should.
Somebody's better buy me a beer now.
No, you need it. Yeah. There you go. Thank you. That went well. Yeah. So where are you off to? You are going to some people, or you have which sheets? Oh, right. Yeah, it's a PCR section. Yep. Yep. Woo! So it would be interesting to know if there were actually problems that I never saw anybody come up on the queue. And it'd be interesting to know if the network problems that people were having in the room actually affected